Okay, in this session, welcome to TechEd 2013 in Spain, Microsoft and Intel's SDN technologies, platform technologies, and initiatives. We're going to hopefully cover in this session basically what needs to happen in order for us to evolve our architectures into a cloud. So we'll do some cloud level set up above and look at some of the market there. Then we're going to discuss network virtualization, kind of get into network virtualization, sort of the trends we're seeing there, and specifically look at NVGRE. And then lastly, we're going to look at SDN, software-defined networks, and sort of what's happening on the Intel front and Microsoft front with regards to that. So up here on the slide, I have a kind of an evolution of the data center. So I've been over 16 years in the networking space. I come as a network practitioner, like I was telling earlier, actually enterprise IT and managing a data center. And we're really at an exciting inflection point, I believe, in networking. Lots going on in that space as we need to migrate our data centers. So 10 years ago, we generally had dedicated servers, and we served our applications from there, but they were somewhat fixed and static. We would use multiple 1 gig ports to service those. And even 5 years ago, and even some applications today, we moved our servers. We abstracted with virtualization a lot of those applications, those systems. So it gave us a lot of flexibility. That's very commonplace today. Even mission-critical systems now are being virtualized, which there was a lot of hesitation at first to do that, but now you're seeing some very large operations that even virtualize mission-critical applications like Exchange. Well, with that, we've moved to kind of today where we really need scalability, this cloud architecture, horizontalizing our architectures so they can service this traffic now that's much more inter-platform. And that's what we're going to kind of go through in the rest of the presentation. So what's driving us, though? What's the trends that are driving us into the cloud? Up here, I just wanted to kind of outline some of the staggering statistics of information. We have 3 billion users pigpiling onto the internet by 2015, according to IDC. 2x growth of our data every double year, so 100%. Originally, when I started studying big data, we thought it was about a 40 to 60% compound annual growth rate of our data sets, but it's actually, according to IDC on this, 100% per year, and we're expected to get value out of these data sets. 15 billion devices connected, so just between mobile devices, the sheer aggregate volume of devices connecting, even if it's a small amount of traffic, is, again, is astronomical, and so it's going to generate a lot of traffic, and our network architectures need to handle that. Also, power. This is an interesting one. I've been working with Intel IT. We have large data centers across the globe, tens of thousands of servers. And they believe in the next 2 years from today, basically, or from 2011 to 2015, that they'll need roughly 30 gigawatts of additional power to power or give energy to these data centers. That's enough to power 10 million homes. That's kind of scary how much power we need to run our data centers. So this is going to be a big issue. All this comes with big challenges. I don't know if you're in IT management of any sort, you know generally the budgets are flat. The head count or the amount of personnel you get isn't growing much, and you're expected to do more with your resources. You're expected to get more return out of your investment. We've moved from a total cost of ownership sort of model to more of a return on investment business model. And then actually getting better insights into our data, extracting value from our data sets because they're big. So that means we have to have the storage to store our data sets, and then we also have to efficiently be able to extract value at it. So all this in the midst of avoiding vendor lock-in. So we have serious challenges ahead of us. So this is really what is driving, I think, the trends for us to move into the cloud. So what does this look like? If you can see from this slide up here, we believe in 2014, so this is in the Grantley-Haswell timeframe, if you're familiar with that Intel platform. We see about 42% of 40% of IT operations will be a private cloud of some sort. So they'll have moved their traditional IT assets into a private cloud. In 2015, so you have to kind of do the math here, but in 2015 it'll be 35%, so 2014 maybe 20% in there, give or take. There's a little bit of crystal ball work here. And then in 2014, public cloud, where we've actually just completely decided to offload those resources into some sort of public cloud adoption, have a cloud service provider take care of that. And we'll see about 40% of operations doing that. So a specific example of what this looks like as far as private cloud was working with Intel IT. In 2009, basically, in order to provision a server, to spin up some sort of server, it would take us about 90 days. Only 12% of those servers were being virtualized at that time, so there was still a bit of reluctance within our own organization to have any sort of real critical assets on there. And then we only had about a 10%, if we were lucky, 20% utilization of that server. So we really weren't getting our return on our investments. So Intel IT actually had a big initiative to move into a private cloud. We have a lot of assets we're not willing to put into a public cloud environment. I'll talk about some of the barriers to cloud adoption. But at that time, for security reasons, we weren't really willing to put into public cloud. Some of those security mechanisms aren't in place yet that we need. So we were able to move these or be able to spin up a server in 45 minutes. So you're going from days to minutes. Now, what this slide doesn't address is that actually there was a 5-day SLA in place to get the network provisioned for that virtual machine. So that's kind of, you can already see the bottleneck emerging here, and that's what we're going to kind of address in the rest of the presentation. So you could spin up within minutes a virtual machine, but then it would take days to get your network piping in place. 65% of our servers have become virtualized, and our utilization is it's greater than 60%. 60 to 80% is what we're trying to look at as far as our utilization envelope. And what I really like down here, managing a data center myself at one time, was that in the right-hand corner, the cost savings. In 2 years, Intel IT was able to realize a $9 million savings from moving to a private cloud architecture. So what's keeping us from this? First of all, risk aversion. It's easy in the technology industry to often forget about this, especially if you work for a technology company. But in healthcare, for example, there's so much compliance pushed down upon them that that's one very real barrier to keeping cloud adoption slower. The other thing is the quality of service. You could have a noisy tenant on that network. That may even be within a private cloud. The accounting department's talking so loud with their virtual machine, chatting away with whatever they're doing, that it could actually starve resources from finance. And so there was a concern over the quality of service. And again, we're building into the platform tools to address that. And then lock-in. This is a big one, actually, public cloud especially, where there's still a lot of, if you put a data set into the cloud, you really don't know if you could transfer that. You really can't today transfer that easy to other clouds, because a lot of those APIs aren't open and able to make the data flow between various types of clouds. Security is a huge one. I actually did a little work in the security, and this is my research days in the labs. Did a bit around security, and I was at RSA a few years ago, actually, and Ken Silva, the CTO of VeriSign, was actually telling me that security, he believed, was going to be one of the biggest hindrances on cloud adoption, because as long as people don't have transparency into that cloud, how can they trust it? Now, there are cryptographic mechanisms that are happening, and I'll talk about some of the platform advancements that could make this a realization, but still slowing down cloud adoption. Scale and automation, and then, of course, standards similar to the risk aversion category. And then last, this is very real, cultural and organizational barriers. The reason I say this is very real is I remember being when voice was being packetized to VoIP. And there was a lot of people concerned. The PBX operators were concerned that they were going to lose their jobs. There's plenty of work to be done. So people, as long as they were willing to evolve their skills, were still employed. But that transition was difficult. The same will be with cloud. A lot of people will worry about their jobs, and so that in itself will keep a little bit of cloud adoption slowing. They have to learn new skills. That takes time and energy. And they're comfortable with what they've done. They've become experts in that field, and as engineers, we often feel we kind of want to stay where we're comfortable. All this on sort of this tenet of cloud security, which I addressed, but the orchestration of these resources and sitting on top of really a balanced platform. And I'll talk about in a little more detail some of what we've put into the platforms to balance it. But really, what is the relationship between the compute, the storage, and the network? Okay, this slide, I apologize, is a little bit of an eyesore, but it's a pretty comprehensive future roadmap the way we see it, the data center rolling out. And what you can see here is, first of all, server optimizations, and we'll get into some of those. But we saw increases in the ability of our server chipsets. One of the things we were able to do was, with a technology called Direct Data I/O, we were able to actually take PCIe and incorporate it into the processor. And by being able to do that, we'd have direct access to the processor cache, and by doing that, we were minimizing memory copies. And so inter-platform, we were able to take the inter-platform bandwidth from 150 gigs up to 250 gigs. So impressive performance improvement, too. Also storage. We're working hard in this area to reduce that storage bottleneck. In a lot of areas, we've seen that this is one of the areas that we're kind of bucking into where we need to figure that out. SMB is a good example of addressing a lot of these problems. But there's that traditional storage interface, too, that is slowing us down. So Intel's been working, of course, on SSDs, looking at this SSD caches, whether tiered model of storage. And then right now, today, we have NAND, but tomorrow you can envision that we're going to be using phase change memory and these types of technology. So continually trying to improve that, and also looking at what those interfaces, if we were to change them, would look like. I'm going to skip over network for a minute here. Address security. I started to allude to this, but we had a lot of security that we needed to do for really the data center to evolve. And we started with this by incorporating in Westmere, if you're familiar with that platform. We incorporated the AES&I into an instruction set, and so we were able to improve the symmetric portion, cryptographic portion of the transaction by 4x, which is impressive. We also did some software optimizations in the form of an Intel performance primitive on the RSA algorithm itself, which also got great performance improvements. And we're looking at and seeing what improving that asymmetric portion of the transaction is. But could you envision a day where you could encrypt all your information? In some ways, you can do it today, actually. Encrypt all your information and put it into the cloud so you don't even have to trust the hoster under you. And that's a very real solution that we're going to try to make come to fruition. Orchestration. Orchestration, I'm going to pick on one specific example. We have a technology called Data Center Manager, which allows you to actually get transparency all the way down to the platform level with regards to power. I was telling you about this power, how much our data center's power we need. Today, usually, we just look at power all the way down to the rack, but that's really not as granular enough as far as we're concerned. So we actually give you insights into the actual server so you can see if you have a server that's really not being utilized well, but is consuming a lot of power, and it gives you a lot of granularity to control your data center and turn on and off servers. So a lot there. And then networking, where we'll focus really the rest of our presentation on. Let's see if I can get that to kind of highlight up there. So in 2012, we really consolidated a lot of traffic. You could see this is really what we worked on and added a lot of virtualization optimizations that I'm going to talk about. But consolidating meaning that we put a lot of SAN types of traffic, iSCSI, fiber channel over Ethernet, over a traditional Ethernet network. So creating that effect. And then now we're really focused on a programmable switch at the top of your rack. So this gives you a lot of flexibility, and this is really that software-defined network, and we'll look at that. And then in 2014, we'll really focus on what does 40 gig and 100 gigabit look like, the implications on your application. With that, I'm going to hand it over to Dhananjay.
Thanks, Matthew. So as we see, Matthew has said together, here's how the evolution of the data center is happening. What I want to do is share with you how does Microsoft think about the cloud, and how are we enhancing Windows Server and System Center and Azure in order to help you move towards that cloud. So I'll talk about a little bit about what are the areas of investments we do, what are the technologies, specifically focusing on SDN and some aspects of storage, and then we'll go back to Matthew on how Intel is helping us get better performance and better scalability with the enhancements they're making. Well, for Windows Server 2012 R2, in order to help you cloud optimize, the 4 key tenets are, we want to go beyond virtualization. We're not just talking about virtualization, taking your physical OSs into a virtual OS, but really providing you a cloud solution that gives you the scalability, the ability to pool and multi-tenancy that you need to secure your workloads and run them in a cost-effective manner. We want to give you the power of many servers with the simplicity of one. We've heard from many of our customers, such as you, is that yes, we want to run this infrastructure on a large set of servers, but do it in a simplified manner. And that's where we are bringing in enhancements in the OS, as well as Windows Server and System Center working together, so that you can manage your infrastructure and maximize your uptime without adding to the cost of maintaining these. Every app on any cloud, we want your knowledge workers to be able to use their apps on any cloud, whether they're talking about their cloud on-premise, in their data center, on their desktops, on their clients, or they're talking about services running in the cloud, such as Azure. And we want to give you the control to be able to do it and enable modern work styles. Modern work styles where your users are bringing in their own devices, and you are giving them the flexibility of the modern workforce, making them more efficient at their roles. So let's dive into, while transforming the data center, why do we feel SDN is important, or software-defined networking is important? Everyone has a viewpoint about what's SDN. Some say, well, it's making sure you have commodity switches and everything's done in software. Or they talk about, oh, it's going to be this whole software-based thing and everything becomes programmable. We really think about it as addressing the problem and your needs, and it's not just hardware or software. It's a combination of both that enables software to dynamically manage your network. What's happening is, as we go towards cloud solutions, customers are requiring multi-tenancy. And the network, as Matthew was saying, gets in the way sometimes, where you have to reconfigure your network, as some of you were very familiar. And even if you want to move your virtual workloads across data centers or within a data center, it becomes a very hard task to do. We want the ability, what we feel is software-defined networking gives you the ability to abstract the physical and the virtual networks, thus breaking those barriers that you have. Spanning those policies across physical and virtual. Creating policies and managing them. When we do it in the Azure data center, you have to absolutely do it such that it spans both your tenant as well as your physical networks. And doing those two separately in an isolated way means extra complexity, more manual steps, and more error-prone problems in your data center. And then when we look at Azure, and we run the Azure data centers ourselves, our team does, one of the learnings we had was, do you know how many manuals, how many different operations have to be done in an Azure data center on a daily basis? Can you guess in numbers? Over 50,000. And if you do those manually, there's no way you can succeed in running a data center the size of Azure. And we are bringing those learnings to you. by making it possible for you to control your data center, the traffic flow, by automating those actions. Those are some of the key tenets that we believe are essential for virtualizing your networks and bringing in SDN, or software-defined data centers, and software-defined networking being a major component of it. Key pillars of our approach, or guiding principles, are flexibility, control, and automation. To give you end-to-end solutions, make sure that we are promoting a standards-based open approach between Intel and Microsoft, such that you don't feel locked into a solution. You can easily plug in and use the extensible mechanisms, which is open, extensible, and standards-based. So you get the choice of picking and choosing the solutions that best suit your needs. So with that in mind, what have we done in terms of some of the solutions we have built? Flexibility is extremely key. As we run the Azure data centers, one of the things that we found is, as Azure was enabling the multiple tenants that they get, is they needed the flexibility to be able to configure their networks. So we built abstractions between the physical and virtual networks in our SDN stack, all the way up to Virtual Machine Manager. Many of the tenants bring in their own IPs, and we can't enforce IP restrictions on them. In order to enable that, we had to enable features such that they could bring in their own IPs, and onboarding was extremely easy. We want you to have control as the same time your users, the tenants, both the service provider and service consumer, to have control over the networks, and an ability to delegate, so you can have a self-service based approach towards controlling the network. As you know, data centers are dynamic, and an ability to dynamically control traffic is also important, so that you can flow those policies and control your network, deliver the cost that you're looking for. We have built into Windows Server an extensible vSwitch, virtual switch that is highly extensible, such that partners can come in and build their own filters and own capturing and forwarding filters that can all coexist at the same time. What you get as a result is a diverse set of solutions that all work together. Some of them are building security firewalls, the other ones are monitoring the traffic, and you get visibility into that traffic by building that extensibility right into the switch. That's where we have built the core of the knowledge of our controller in SDN. And then finally, automation. Through PowerShell, we enable our automation, which gives you the power to automate most of the manual steps that we have, and give you ability to provision your load balancers, provision your VPNs, provision your gateways in an automated fashion using VMM. So those are some of the core investments we've made in Windows Server 2012 R2, as well as System Center 2012 R2 that you'll be coming up with. So let me quickly switch into storage too, because Matthew is also going to talk about a few of the storage enhancements that Intel and Microsoft have made. All of us are familiar with file shares. And with Windows Server 2012, we allowed you to not just store documents, but also allowed you to store Hyper-V, VMs, onto those file shares. We are taking that even further with SMB 3.0 support in Windows Server 2012 R2, as well as in Windows Server 2012. So you can, in the past, you needed fiber channel or iSCSI arrays or SAN arrays to store these things, to get the automation, to get the scalability that you're looking for. We are bringing it to you with really low-cost JBORDs with the similar set of capabilities, so that you can have a much more scalable data center. This is bringing in all our learnings from running Azure Data Center, running Bing, running Office 365, and giving you a simple file share based approach into running your data center. so that you can have a single logical share where you can store these. Whether you're running SQL loads on physical or virtual, or also your hypervisor workloads, into creating highly available solutions for your customers and for yourself, which gives you increased flexibility, gives you an advantage of using your existing infrastructure, network infrastructure that you already have for file shares, instead of putting in a new one, and gives you absolutely line rate performance with some of the enhancements Intel has made right into the chipset. And these enhancements are going to go to NIC vendors as well as to gateways and load balancers and other appliances that will come along that will build our whole ecosystem. That's why our partnership with Intel was key, both in network, compute, and storage areas to bring you those enhancements. And whether it's SANs, traditional SANs, or whether you're talking about storage spaces, you as the customer have the choice to implement and migrate towards the cloud solutions that we are building, with Microsoft and Intel providing you the technology that you need and the simplicity with the flexibility, automation, and control that you need to get there. So with that, let me hand it back to Matthew, and Matthew will go through some of the enhancements Intel has made.
Thank you, Dhananjay. So why is a networking guy like me talking so much about storage in this presentation? This is a great use case, though, for a lot of the platform optimizations we've done. And with SMB, Server Message Block 3.0, we've really pushing the I/O of the system, not only the storage I/O, but what glues it all together, the network. We're trying to make this remote storage look just like as if it were local storage and with that kind of performance. So with that, we've developed a few. There we go. We've developed a few interesting technologies in a partnership with Microsoft. And the first one is really this concept of multi-channel. So without multi-channel, everything was looked at as just really one TCP/IP connection. And what would occur is when 10 gigabit would come in, you would often just go to the first core in the platform and quickly overwhelm your system. You could, with 10 gig, overwhelm that core and then effectively get this sort of bottleneck and not get the not get the return on your system investment because you're really not able to outpace the CPU. This is very similar in the 1 gigabit space. We were overwhelming way back when. This is when I started almost 14 years ago when we were going from fast Ethernet to 1 gigabit. We had this problem where we overwhelmed the system with I/O. This, again, happened in the 10 gigabit space. So what we did was we worked with Microsoft on using multi-channel to leverage an offload capability we call RSS, receive side scaling. And what that did was it allowed us to take our 10 gigabit and actually distribute the load, the I/O load, across the various cores. So you could effectively then add more and more 10 gigabits. So in this case, we added I guess we did on both. But we overwhelmed the system. So in here, we have 20 gigabit that's actually feeding all these 4 cores. Then we also worked on a technology, LBFO, load balancing failover teaming with multi-channel. Now, there was proprietary instantiations of this. We actually had one, AS&I, that allowed us to do this. But it was a proprietary little application in ProSet that basically allowed us to team. But again, working with Microsoft, we were able to create this ability to load balance on them. What was happening before we had multi-channel and you were load balancing with these utilities that each vendor would come up with themselves, is you weren't able to actually you could get NIC failover, so you kind of had this active-passive configuration, but you weren't able to actually take advantage of both NICs, sort of having this active-active. So with LBFO, this load balancing failover, first of all, we just improved the user experience. You as a system admin now kind of have a common experience going through the Windows operating system as opposed to dealing with different vendor tools. So we're a big fan of that, just creating a better user experience. That's one of the reasons people use Microsoft Intel solutions. The other thing is we were able to take advantage of all the bandwidth, so we could add more and more NICs or adapters and no longer have to do this sort of active passive sort of technology, but now we could combine the bandwidth of all of them and take advantage of all of the multiple NICs and engage multiple cores. So we could really affinitize the cores with their various flows. This is what the performance looks like. You can see here. We show a 1x10 adapter, a 2x10 adapter, a 3x10, and a 4x10 adapter. And really what's going on in this picture here with the performance, as you go up into these large size packets, you're seeing that you get this linear scaling of your network. So really showing the balancing of the platform. So now you're no longer getting this diminishing return, which would happen in the past, where you would quickly overwhelm your system and then you wouldn't get your performance and then your investment wasn't worthwhile. So here you can keep adding I/O to the system and scale it linearly, which is impressive and will make technologies like SMB very impressive as far as storage. Another thing is we're kind of transitioning a little bit into the virtualization space here. But, you know, this is really a before and after picture. You have your physical servers. They're connected to a top-of-rack switch. But with the advancements in Hyper-V, we've really taken a lot of that physical top-of-rack switch functionality and brought that down into the virtual switch. And so that virtual switch has really replaced that top-of-rack and has a very rich environment in it. And often it's much easier to change it and upgrade it because it's a software environment. And because of certain optimizations that we had been done in the platform, we were able to get excellent performance in there, 60 to 70 gigs within the virtual switch. So if you had a VM1 talking to VM2 on the same platform, you could get 60 or 70 gigs, which is better than actually PCIe Gen 3. By 8, right, which is a 56, right? It says theoretical 64 gigs of throughput with PCIe Gen 3, which is coming online. So you were able to get 60, so double that. So here's some of the functionality that was brought down into that hypervisor switch. You can see that you have your ACLs, PVLANs. I went to an excellent talk earlier this week. It was talking about configuring these different technologies. I'm just going to pick out a couple of these. In traffic shaping, you're able to do bandwidth, limit your bandwidth is what I'm trying to say. IPsec offload, one that's very, not all NIC vendors have IPsec, so now you're able to do that within the virtual switch, so that gives you that functionality. And because of the encryption, the encryption that's been put in the processor, you're able to do it effectively. Dynamic VMQ, which I'll talk about in a little bit, and port mirroring. All this we coupled with the network controller with our stateless offloads and our network assists, whether it be VMQ or SROV. I'll talk about that. It was all down in the switch, giving us just a tremendous amount of functionality and a really rich environment. So here I'm going to talk about briefly dynamic virtual machine queue and SROV. By being with virtual machine queues, VMDQ, or VMQ as Microsoft uses the term, you were able to use RSS and actually peanut butter those loads across the network, the CPU cores. But that's not always a good idea. So here we had you could actually create a lot of core interrupts. And so in certain situations, you may actually want to, if there's not a lot of activity going on in the system, affinitize those flows to one core to reduce interrupts. So you could actually optimize your system. So with VMQ, you were actually able to dynamically determine with just kind of a coordination within the platform, what's the ideal optimization to get with I/O of those virtual machines. So really mapping the VMs and their queues to cores appropriately. Now there are some situations where SROV may be required. Single root I/O virtualization. Now this technology is interesting. It actually bypasses the hypervisor, but it's like any traditional offload. There's a place for it, but it comes with a trade-off. So in certain applications where small packet performance is required, usually sending it out to the PCIe card, can give you that. And so with SROV technology, you can bypass the hypervisor. However, that rich switch functionality that I showed you before, you now lose. All that ACL, port mirroring, and just a total switch infrastructure, you now bypass that. So if you have deterministic traffic, like in a network function virtualization environment where you're trying to abstract load balancers or firewalls, and you know what those traffic flows look like, it may be appropriate to bypass the hypervisor. So let's take a look at what the performance looks like. You can see over in the left-hand column on small packet performance is pretty impressive, but you can see that once you get up into larger packets, really the effect on the CPU utilization becomes nominal. And so you really have to look at whether you're using a lot of small packet performance. But on that, you can get up to 47% improvement in your throughput. And you can bring down your CPU utilization as much as 26% if you're doing a lot of packet performance. So you can envision in a comms application, or we formerly refer to it as a telco equipment manufacturer, where you're making a network appliance or trying to virtualize that appliance with network function virtualization, this would be an ideal technology. But again, it's an offload, so you get rid of a lot of the functionality you get in Hyper-V. So we still, though, I'm going to kind of transition now the presentation into more the challenges that are happening on the network side. So all this virtualization has happened, and Intel and Microsoft have worked together to really reduce a lot of the platform bottlenecks. We've really looked at it more holistically and reduced those so you can have a lot of I/O in the system. Well, we've come to that example that I gave you earlier. You can deploy that virtual machine within minutes, get great performance out of it, but you have a 5-day SLA with your network, and there's a lot of limitations on that. And that's what I'm going to go through. You have operational complexity like never before because virtual machines are just compounding the problem. Provisioning it takes forever, and we really don't have a lot of control over those traffic flows. So let's take a look at that. Get it? There we go. We virtualize the network. What's next? Virtualize the server, sorry. Got a little ahead of myself. What's next? We're going to virtualize this network. So this portion, we're going to talk about network virtualization and then kind of transition into software-defined network and how those two complement each other. So I'm going to actually use those red-blue examples. Here, we're using a traditional VLAN, and I'm going to kind of create a little animation build here. You have your server administrator here, comes online, creates a virtual machine, and wants to now get the plumbing necessary for that virtual machine. And so it requires them to configure these. You can see him popping up there. He disappeared. Let's see if we can get him back. And therefore, you can pass the traffic. But there's definitely a coordination that happens between the server admin and the network admin. But this, of course, becomes complex when you have to go across the data center. You may have multiple teams. You can kind of see the proliferation of who's involved. And anybody who works on a large enterprise team can kind of relate to this. Once you get multiple network admins in place, then this is where the 5-day SLA comes in place because they got multiple teams that they're working with. This is a horrible experience. I've lived in this world. It's been a little while since I've managed a data center or been part of this, but the actual moving cables around, setting up VLANs, 802.1q VLANs, it's arduous and it's really quite hard. And that's 5 days. It's not them just sitting around doing nothing. It's just a lot of work and a lot of coordination. So there's got to be a better way. And we're going to find out that. There we go. So we start with Hyper-V and some of the benefits that it brings to us. First of all, to the application owner, we're going to see that Hyper-V can bring seamless migration. You can bring your own topology to the network. So if this is a private cloud, or you can even take it, and I'll show you, into a public cloud if you're going to burst an application so you have cyclical traffic. Use the example of an accounting company in the United States around April. That's tax season. It gets tremendously busy for accounting companies. That would be a great application that you could burst into the cloud. And we're going to show you that. But can that application really change with all the infrastructure under it? And often not. It's a big problem. They can't bring their own IP. To the enterprise and private cloud, again, this gives you the opportunity to do these hybrid clouds. You could have resources inside your own cloud and outside your cloud. To the hoster, really bringing your own IP. This is huge, and I'm going to talk about this a little bit more in depth on the next slide. But the ability to keep your network scheme is huge. Once you do that, everything breaks. If you're asked to change your IP scheme, especially your virtual machines, you're reconfiguring them. So if you're able to take that topology and put it into the cloud, that's a great opportunity for cloud service providers to differentiate and attract your business. Ultimately, that's what they're after, is getting some portion of your business. Even if it's not a mission-critical app that you would never take in there, you'd always leave it in your own private cloud, there are going to be applications that you'll be happy to offload because it just makes more sense. This is much more attractive offering if they can do that. And then lastly, just to the private and public cloud data center admins, it's going to make life a lot more flexible by decoupling the servers and the network admin roles. So no longer do you have to have two different teams orchestrating the network, the server, the virtual server, and the network together. So here, I'm going to talk about standards-based virtualization, non-volatile generic routing encapsulation, MVGRE, now being called Hyper-V network virtualization. You'll see that come on. This is kind of a new branding of this. But Hyper-V network virtualization, and we're going to kind of talk through that. Excuse me, I took a lot of work to learn MVGRE, just commit that to memory, so it's going to take a little work to decouple that bad habit to get to Hyper-V network virtualization. But let's kind of go through this and see what this looks like. Now, I'm going to use the canonical example. You kind of have Pepsi there in blue and Coke in red. I like that example because the two shall never meet. They want to be isolated. They wouldn't like to even know that they're on the same server, right? So you have, they both have decided that they want a 10 network. I mean, there's only 3 private networks in the world, right? You got to pick a 172, a 10, or a 192. So it's not really outlandish to think that Coke and Pepsi would both choose 10 networks for their networks. And they both want to burst into the cloud. So you have these two. They have their customer addresses. We're going to kind of build this out. They build it. And you can see the blue machine, Pepsi's machine. It goes across the network. So that kind of built quick. But what we do is we take their 10 network. We add a MAC address to it. That's the IP packet, excuse me. And we add the Ethernet packet. So you have an Ethernet frame, excuse me if I'll be technical here, an Ethernet frame. We add a GRE key to that, and that gives them their ID. I'm going to pause for a second and explain that GRE key. Generic routing encapsulation, it was developed by Cisco a long time ago. Telcos actually have been using it for quite some time for encapsulation method. So because Hyper-V's network virtualization, practicing, it's very standards-based. They've basically modified that. They added 24 bits to this header, so that allows them now, if you take 2 bits to the 24th, that gives you effectively 16 million addresses. That's beautiful, because today, with 802.1q, you really only have 12 bits. So if you take 2 to the 12th, you have 4,096 addresses. You can imagine any sort of cloud service provider that has a multi-tenant environment, or even a private cloud like Intel IT's private cloud is chewing through 4,096 VLANs really quick. But there's something that I think is even much cooler than that. The fact that then we encapsulate it with an IP header that allows us to transport these layer 2 networks across a data center. So we're creating these islands or layer 2 network adjacencies. This is really nice. So then you can still have a flat network and pipe it across your data center, or put it up into the cloud as we're seeing here. So you can take that 10 network and bring it over to the virtual machine, and they get to keep the same IP. So now we see Coke, and they also have it, and we encapsulate, and they too have the same network scheme. So this is what I was talking about, bring your own IP. You can have that 10 network, it's no problem on the network. You have a provider address that we anchor it to. That's that outer IP address, and that's how we route it over across one network to another, whether it be in our own data center, in our own private cloud, or whether we're bursting up into a cloud service provider. Okay, so here's kind of a visual of how this all looks together and how it's just kind of seamless. The virtual machine admin can make it a lot simpler than last time. And let's see how this builds out. And the traffic passes without any involvement required from the network admin. But now we're going to do it across the network. And again, there is no reconfiguring. This has all been abstracted, so the actual network is now transparent. So though what happens over here is you still have these data center policies that are associated with this. And that can become quite complex when you have to assign the VMs into these. So if the provider address network changes at all, that can be quite cumbersome still. So this is why technologies like System Center Virtual Machine Manager can manage all those policies, and Microsoft is doing this in an open way. So by using these types of technologies, we can basically make this all really a very easy and automated system. So again, the Azure example of taking 50,000 transactions and making it bearable that you can manage. So I actually will in a second talk about that, but why SDN and why it's so important in the cloud? I'm going to kind of transition. Really, the first thing is we want to decouple that control plane from the data plane. By doing that, it'll add a lot of flexibility to our network infrastructure. It also helps us centralize. The reason centralization is so important to a lot of us, now, although it doesn't have to be, is because often that allows us to consolidate roles. Yeah, so if you have really somebody that you have as a cloud administrator now that you've defined, and they're creating the systems and the networks all together, will have to become more proficient across boundaries here. There's a little bit of a melting of boundaries, but by centralizing it allows you to really have a centralized cloud administrative team as opposed to a network team and a server team. And then the abstraction of all this. By abstracting it, you get all sorts of innovation that we can do with this. By putting it on a central controller, we'll see a lot of innovation. So developed a little bit of a analogy here. Hopefully this will resonate. I like working with analogies. But you have a rental house, an apartment, and a hotel. And this might give you an idea of why we really need this. And days have passed when we just deployed a server. It took a long time. You had one server. But changes were infrequent. You knew you were going to host that application for a couple of years. It was long term. That was okay. And you tried to get the most investment out of that server. And usually, you may even have an admin for that entire server and that application. Whereas now we've virtualized the system, or think of the apartment, and you have several tenants coming in and out of here. And the changes are occasional. You can see that, but there's turnover, and there's probably a building manager. So definitely more people involved here. Now with a hotel, this is really, and I'll show you on the next slide, but you're going to have people coming in and out every day, potentially, and because it's daily, you have to really lower your capital expenditures. Getting people in and out of the hotel is really important, because if you don't do that in an economical way, there's no way you're going to be able to compete in the market. And you have a staff that's going to do all this. So let's superimpose our server world in here. You can imagine the dedicated server, which I already talked about. Virtualization is occasional. But in a cloud environment, we really, and that's the benefits of the cloud environment, is to be having many changes and really getting that staff to be able to configure this quickly and efficiently so you can get people in and out every day. So the benefits of SDN, and we're going to talk about this a little bit, is programmability and automation. We really need that ability to have flexibility within our environment so we can get people in and out, as you would use the analogy, and significantly reducing our cost of our operational expenditures and, for that matter, our capital expenditures, as I talked about earlier in the presentation, because you're getting more return on investment out of your systems. So what does it look like? This is a central view of how you would do it, but you're basically taking the network. I like to think of it as giving your switches a lobotomy and taking all that and abstracting it at a higher level. So your SDN, your software-defined network controller, really has all of the intelligence in that. And so you've taken that out, and you're just exposing potentially an API of the switch to the software-defined network controller. And by doing that and centralizing the brain, you can do a lot. You can have a much richer environment for a lot more innovation and a lot more control by having it centrally managed. So what is Intel specifically doing? We've developed actually architecture, a platform, a reference platform, using basically Intel general purpose processing. So it gives a lot of flexibility for the development. You can do a lot on there. It doesn't necessarily mean it's the switch is dumb. There could be a lot of flexibility in there. So if you wanted to do a more disaggregated version of this. And then we've also used the communications processors, so you get the performance. And then our FM 67000 switch, which gives us the performance. And I'll talk a little bit about that particular switch in a minute here. Doing all this, we put an operating system on there, ONS in this situation, our open network software. And that allows really for all sorts of innovation to happen on top or within the, and exposing an API, so there's a lot of flexibility. This particular reference platform, it's not a switch we sell. It's just a reference platform where we sell the ingredients of the networking piece. But it'll allow us to support SDN legacy networks. It'll optimize for flexibility. I'll show you some of this. It'll offer flexibility, the FM 6000, in tagging because it has a feature I'll talk about called FlexPipe. And then last, we know we have to deliver uncompromising performance, meaning you want to go to this SDN environment, you can't give up the performance of your environment today. So you want flexibility, but you don't want to give up the performance. As a matter of fact, you can't afford to because as you go to a cloud, you need to be able to service these workloads even actually more efficiently. So Intel FlexPipe, the technology inside of the FM 6000, really gives us the ability, it's a programmable pipe that sits on top of the gates that allows us, despite the fact that the silicon is baked, if you will, to still support emerging standards, for example, or technologies. So for like tunneling, you can envision having Trill, or maybe even a proprietary version of MPLS, like telcos will use, and adapt headers. You could do that with FlexPipe, actually program the switch. Network overlays, both VXLAN and NVGRE, but these standards are still very new. So as these standards continue to mature, you can envision changes within them. And despite that the silicon is already laid, you can still make those changes in there, but get the performance. Oh, and then virtualization, a tighter coupling, Ethernet virtual bridging, and also VEPA, virtual Ethernet port aggregator, port aggregator. And I didn't say that acronym right. This is the Flex 10 instantiation of the standard, 802.1 QBG. But the tighter coupling between virtual edge port aggregator. Sorry, it took me a second. Too many acronyms. The virtual edge port aggregator is a ability to tightly couple the switch to the platform. And this is becoming more and more of a ability to blur those lines, and this is important. And FEX, or VNTag, Cisco's version of this, of tightly coupling the switch and the platform. So these are all emerging. There's a lot of different standards coming out, so you can still do that, but still keep the performance that you would with 960 million packets per second, which is the most impressive packet performance on the market. So with that, I'm going to pause here for a second, catch my breath, and show you what the gateway and the network are. A network virtualization gateway is. Oops, pass through this. By incorporating, it wasn't a build, by incorporating, no, it doesn't build, NVGRE and network virtualization, hyper-virtualization, network virtualization into the top of a rack, what we're able to do is actually encapsulate and decapsulate the environment. And what that does is you have to terminate your tunnel. Usually you would do that in Hyper-V. But you may have legacy systems. You could envision this rack here over on the right. Maybe it's a mainframe with a critical database application. That doesn't mean, though, you don't want that database to interface into your virtual environment. So it doesn't have to support those new standards. What you could do is terminate the tunnel at the top of the rack and still get that legacy system interfaced into your virtualized network environment. And so what this is showing is just on the top of rack. Ideally, if you're running Hyper-V, because you're going to get a lot more functionality, you would basically terminate that tunnel in the platform, into your actual platform within the rack. But in situations where you can't do that, it's nice to do it at the top of rack. It's also important to look, oops, I didn't build, but orchestrating all this, that we're just going to have to really think about it from a standards perspective. So working with Microsoft, we will use SIM-based standards, adhering to the OMI, basically using OMI to basically orchestrate all this and looking at standard APIs to expose all those to you so that way you don't have vendor lock-in. And so that's really important piece in putting this entire architecture together, that you don't have a vendor lock-in. So with that, I'm going to go ahead and have Dhananjay come up and kind of...
So delivering software-defined networks. This is possible today. With Windows Server 2012 R2 and System Center 2012 R2, we can deliver Hyper-V network virtualization as well as with the extensible switch. We have put some of the core technology in the extensible switch, in the VMM plugins, and in the core of the Windows Server networking stack to enable these technologies. And jointly with, as Matthew went through the whole presentation, with the Intel's Ethernet building blocks, we're bringing optimizations to that switch. We're also bringing along gateway solutions that you can deploy so you can bridge between have forwarding gateways or even load balancing gateways. And then with Intel's open network platforms, you get a much more scalable, pluggable model with Windows Server and System Center. So,
So hopefully you've got the excitement. I know these are long presentations. There's a lot of detail in there. But we're really at the inflection point of, if you know, cloud, and everybody's heard that word. It's almost trite anymore. We've overused it. But really that our architecture has changed, but our network has to change as well. And that's why I'm so excited, because with the advent of network virtualization, we'll really be able to abstract a lot of the complexity of our networks, have a lot more flexibility with it by potentially keeping like IP schemes, by creating these islands so we can provide services to our customers, whether it be on our premise or without in a cloud. We'll have a lot of flexibility with that, and so it'll add a lot of creativity to the networking world. And then SDN playing even more into that. By decoupling that control plane from the data plane, there's, I envision, with especially all sorts of different open standards and software, that there's just going to be a boom of creativity, and we're going to really see this, our job as cloud administrators, really just blooming and getting more exciting with time.
Yeah, and software-defined networking brings flexibility, control, and automation. This is possible today. Go out there. I know some of you have already started doing POCs, and do give us the feedback. What would you like to see? Where are we? We kind of shared with you the roadmap where we are heading. Thank you. I know we saved the best for last, so thanks to all of you who came here in the last session for TechEd. Do give us the feedback. We really value your input because you are the most dedicated of the folks who came here at TechEd. And thank you so much.
Thank you, guys. Thanks.